This brings us to the end of One Way ANOVA. To summarize, let's ask some basic questions which we are going to come across while using ANOVA. So to begin with, how do we go about comparing the performance levels of two or more samples? Now we know we should use ANOVA. And why should we use ANOVA? Because ANOVA helps to test our hypothesis, and it determines if the sample means are statistically different. If in my analysis there is only one factor, but this factor has more than two levels, where do I start? Which tool do I use? So we use One Way ANOVA, as it is designed for one factor with many levels. Before using One Way ANOVA, do I need to be aware of any specific requirements? Yes. One Way ANOVA requires the design to be balanced, that is, all subgroups must have the same sample size. It also assumes that the observations are independent. There is homogeneity in variances and data in each group is normally distributed, though it holds good with nearly normal distributions also. Okay, so how do we interpret the findings from One Way ANOVA? Okay, coming to the interpretation, first we check the p-value. If it's less than the significance level, which we normally take 5%, then we reject the null hypothesis that sample means are similar. It would mean we have enough statistical evidence to believe that the sample means are statistically different. Next, we check the confidence intervals. If the intervals overlap, then the inference is that there is not enough statistical evidence that the means are statistically different. Okay, ANOVA says it's statistically different, but I want to know which factor level is better. Then what do I do? Then best is to follow up ANOVA with ANOVA, or analysis of means, because it helps to find the best factor level. The factor level that's outside the decision limits is statistically better from others. Within ANOVA also, we have Tukey's test, which can be used to study the pairwise comparisons of means. This test uses the confidence limits, and if the confidence limits include 0, it would infer that the pair is not statistically different. So pairwise, compare which mean is better, and in the end we are left with the better performing factor level. I hope this video was useful. We would always be delighted to see your likes, comments and mails, as we consider you an integral part of our learning endeavor. Keep watching this page as we plan to host more learning videos on concepts from DMAC, Lean, DFSS, re-engineering, theory of constraints, BPM and operations research. Please do subscribe to the page and keep receiving updates as and when we upload a new tutorial. Do share the links or channel details in your group so we end up creating a much larger learning community. In case you want us to talk about any specific concept, feel free to contact us. The contact details are mentioned here on the slide as well as on the page. So good luck and happy learning.